All right, welcome back. So we're going to even get more understanding of this backpropagation through time problem. All right, so we said that there's a problem with long-term dependencies. Okay, long-term dependencies. Well, let me explain what I mean by that. Okay, so we are trying to figure out why we still need more efficient NLP algorithms, right? Although we say that RNN is very much efficient. Okay, we say that RNN is very much efficient, but we're trying to understand why there's still more variants of RNN out there. Okay, so we have another problem we call long-term dependencies, which also lead to the exploding gradient or the vanishing gradient problem. Okay, the exploding gradient or the vanishing gradient problem. So all these are leading to that exploding gradient or the vanishing gradient problem. Okay, now consider the statement or the sentence, the clouds are in the sky. Okay, this is just a simple sentence over here. The clouds are in the sky. Now, let's say that I want to predict, say, sky, right? Let's say I want to predict sky. Now, if I want to predict sky, it's quite easier for the RNN model to do that because, as I said, it keeps track of the previous words that will come and then based on that predict the last item. Okay, so for instance, if it knows that okay, these are the previous instances or these are the previous states of the sentence, it's likely to predict the last word. Okay, it's likely to predict the last, because the distance from the word that we want to predict to the keyword. So for instance, if we know clouds, right, if RNN get to figure out clouds, it will be able to easily predict the sky. Okay, and the distance from the sky to the cloud is not that far, right? We just have R, in, and then there, just 3 words in there. Okay, so the distance over here is not that far, okay, from the rest of the sentence to predicting the target word. Okay, it's not that far, right? So in that case, it will be easier for the RNN model to predict it. Okay, now let's take another scenario over here, right? Let's say we have this sentence here, which is saying that I grew up in France, and then some other sentences or statements. Okay, so let's say it's a conversation or it's a huge text over there, right? And then the outer is talking about where he grew up, what I like to eat, and all those kind of things, right? Talking about himself. So a lot of things over there. Before somewhere down there, right? So it's a large corpus, okay, or a large document, okay, where the author is talking about himself. So he started with I grew up in France, okay, something like that. And then I like eating maybe banana, I like playing soccer, I watch football every evening, something. And then I speak French fluently, is somewhere down there, okay, or I speak fluent French. Now, let's say that you want to predict French, okay. If your RNN model, okay, or if your RNN algorithm is able to figure out France, okay, the keyword France, it will be able to easily predict French, okay. But for it to travel all the way back in time to figure out where France is, it's going to be difficult, okay, because the distance from that keyword, okay, that keyword all the way to the one that you want to predict is very far, okay, it's very far. There are some others, the other sentences or keywords in here, right? So there will be a lot of interruptions to actually figure out, go all the way back in time to be able to figure out France and then link France to French. Okay, that becomes quite a challenge over there. And if your RNN keep on travel back in time, remember, it's going to keep on multiplying the weight, right? If it's doing backpropagation, right, it's going to keep on multiplying the weight. So maybe W1, W2, W3, W4, W5, or maybe W1000, something like that, right? Before it reach that keyword, okay, it's going to end up having exploding gradient. If your W is very small, you're going to have vanishing gradient. But if your W is very large, you're going to end up with exploding gradient, okay? So all these are becoming a problem for RNN to figure out. Okay, so several versions of RNN has evolved over the years, right? People try to solve this kind of a problem that RNN is actually having. Okay, so we're going to now see the various variants of RNN. Okay, so if I talk about variants, I'm talking about the different types. Okay, So I'm talking about the variants, the different variants or different types of RNN architectures that we have. All right.